Frequentists believe as the number of trials increase, the relative frequency will get closer to the probability of that event. And it is proved by the law of large numbers. The law of large numbers tells us, as more trials performed, the frequency will tend to become closer to the probability. In another word, the value of frequency will bound. It is a range around the value of the probability. This range is known as the margin of error. Differs from the frequentist interpretation. Bayesian probability expresses a degree of belief in an event, which enables us to compute and update the probabilities after obtaining new data. It is based on prior knowledge and updates when new information emerges. Well, you probably feel based on prior knowledge is not that reliable, for prior knowledge could be very limited and even wrong. In that case, is frequentist probability better than Bayesian probability? Let's see an example. The Monty Hall problem. It's based on a TV show, Let's Make a Deal, and named after its original host, Monty Hall. Here is the puzzle for you to solve. There are 3 doors in front of you, and there is a prize behind one of them. Once you select a door, the host, who knows what behind the doors, will open one of the other doors that not have a prize behind it. You will then have the opportunity to switch from the door you originally selected. The question is, should you switch? Let's first apply the Bayesian theorem. Here, PA is the probability of the prize is behind the door A. It is 1/3. PB is the host opens the door B. There will be 3 situations here. 1. If the prize behind door A, the probability of the host open door B is 50%. 2. If the prize behind the door B, the probability of the host opens door B is 0%. 3. If the prize behind door C, then the host's only choice is to open door B, so the probability is 100%. Put these 3 situations together. PB equals to 50%. PB given A is if prize behind door A, the probability of the host opens door B. Because the prize is behind door A, so the host will choose between door B and C, which means PB given A is 50%. Plug all these numbers into the Bayes formula. We get PA given B is 1/3. This means if you stay, the chance of win is 1/3, and if you switch, the chance of win is 2/3. Now, let's apply the frequentist approach to solve this problem. How? Easy. Let's simulate this game many times, and it will be clear from the simulation result whether it is to your advantage to switch or not. I'll write in some code to simulate this game 10,000 times. Here is the result. Run the code again. And again. And again. As you see, after repeating the game many times, the result is great well with Bayes' approach. So, I hope this can assure you both approaches can reach the right answer. The difference between them, Bayes and the frequentist reasoning, are distinguished by 2 different ways of answering the question. The Bayes approach is subjective and uses prior beliefs to define a prior probability distribution on the possible values of the unknown parameters and then update new information. The frequentist sees probability as something that has to do with a limiting frequency based on an observed proportion. The problem must be well defined, so it can repeat as many times as wanted. Then, because of the law of large numbers, we will get closer to the answer. First, Both approaches can take you to the right answer. Second, they are distinguished by two different ways of answering the question. I'm always here at your service. See you in the next one.